In my last video, I showed you how you could put together a simple weather station using a Raspberry Pi Zero and a BME280. This time, I want to do the same thing, but use a Raspberry Pi Pico. It's a very different ecosystem to the Zero, and so we'll have to do a few things differently. But let's get to it. Hello once again, Pi geeks and techno nerds all around the world. My name's Jeff, and I'm an IT professional who's been in the industry for over 30 years. In my spare time, I like nothing more than playing around with Raspberry Pis. I'm sure you do too. If you like what you see here, please hit that thumbs up button, subscribe if you want to see more, and hit that notification bell so you can be told when I put new videos out. And also let me know in the comments what your favourite Raspberry Pi projects are, and if you've got any ideas for projects that you'd like to see me do, leave those in the comments as well. In my last video, I put together a simple weather station using a Raspberry Pi Zero and a BME280. They work great, but the Pi Zero is a little bit overkill for this. It's a general purpose computer, albeit quite a restricted one. And for this kind of task, we can make use of the Raspberry Pi Pico. Now it's a microcontroller rather than a general purpose computer. What this means is, when you first power it up, it immediately starts executing a particular task, and it will just keep on doing that. But there are some drawbacks. Coding for the Pico is a lot more difficult than the Pi Zero, because you don't get so much for free. There is no operating system as such, so you don't have immediate Wi-Fi support or a web server or anything like that. So there's way more that we've got to do for ourselves. But that can kind of be an interesting challenge in itself. So let's go and take a look at the kit that you'll need for this project. Now there are a lot of options with the kit list for this particular project, so I'll go through some of this now, and you can then just go ahead and buy what you want. The first thing you're going to need to buy is the Pico itself. Now the version of Pi Pico that we want for this project is the Pico W. This is because it has support for wireless networking built into it. But you can see there are two flavors here. There's the Pico W and the Pico WH. The WH comes with the header pins pre-soldered onto the board, whereas with the Pico W, you have to buy and solder on the header pins yourself. Now the header pins are readily available. Pimeroni have an option here for £1.80. Or you can buy big packs of header pins such as this, which work out a lot cheaper. But you need to figure out what the best option is for you specifically. If you're only doing this project in isolation, then you may well find that the Pico WH is the best solution for you. Now the next thing you'll need is the BME280 board. As you can see here on Pimeroni, there are several options available again. For the purpose of this video, I purchased the Adafruit version, but this was really only because the Pimeroni version was out of stock at the time. As you can see, it is a little bit cheaper, and it's also easier to program for, as we'll see later. Just like with the Pi Pico, you'll need header pins in order to be able to connect the BME280 to the Pico itself, so just bear that in mind. Now the next thing you'll need to think about is just how you want to connect the Pico to the BME280. The easiest way to do this is just by using some female to female jumper wires, and these then just simply connect the pins from one device to the other, and it ends up looking like this. It's a little bit messy, but it is functional. An alternative and neater solution is to use this stuff. This is PCB board, and as you can see, you can get it in a whole variety of shapes and sizes. You can then buy header pins such as these that are specifically designed for the Pico and solder them onto the PCB board. Or alternatively, you could buy a pack of sockets such as this one. Although I did buy a set of these and I found that they were actually too narrow for the Pi Pico, so I had to cut them in order to make enough space for the Pico to fit. But as you can see here, the end result can actually be very satisfying. I've got a pair of header sockets that I can plug the Raspberry Pi Pico into, and then I've got another smaller set of pins that I can plug the BME280 into. If I look at the reverse side, you can see that I've just soldered wires between the relevant pins to provide the connectivity that I need. Now it may not be pretty, but it is functional. And once the Pi and the BME280 are slotted into place, you can see that it makes actually quite a pleasing little circuit. Now, obviously, just showing you that soldered board or the mess of the jumper wires connecting the Pico to the BME280 don't really show what the connectivity is. So I've put that into a diagram that you can see here. The V-in port of the BME280 connects into port 36 of the Pi Pico. This provides a 3.3 volt power supply. The ground port of the BME280 connects to pin 38 of the Pico, and this is just an arbitrary ground pin. I then connect the SCK port on the BME280 to pin 2 of the Pi Pico, and this is labelled I2C SCL. The last pin connection is the SD1 pin out of the BME280, and I connect that to pin 1 of the Pi Pico. And this is labelled I2C SDA. Now I just want to talk quickly about the subject of soldering. Of course, it's quite a dangerous thing. Not only is the soldering iron itself very, very hot, so you've got to be very careful when you're using it, but also there's the solder itself. Now I use only unleaded solder. Now this has a higher melting point than leaded solder, so it's a bit more tricky to use, but it is worth it. Lead is a toxic substance and it is a carcinogen. And especially this week with the news that Steve from Tronics Fix put out. If you've never seen Steve and his channel, he is absolutely brilliant. He does all kinds of electronic repairs. But this week he put out a community post saying that he's just been diagnosed with non-Hodgkin's lymphoma. Now, non-Hodgkin's lymphoma is a form of blood cancer, and one thing that has been related to it is the use of lead. Now, I'm not saying for a second that it was the lead solder that Steve uses that has caused this for him. He may well just have been unlucky. But I just want to stress that if you are going to use leaded solder, please consider using gloves, or at the very least wash your hands really, really thoroughly when you're finished. And make sure that you are always in a very, very well ventilated area whenever you're doing any kind of soldering activities. Electronics projects are really, really great fun. I enjoy them a hell of a lot, but just be safe while you're doing it. But of course, right now, my heart goes out to Steve. I hope you have a very, very speedy recovery. Now, back onto the happier subject of the project. The last thing that you'll need is actually software, and this is Thonny. It's a Python IDE that has built-in support for talking to a Raspberry Pi Pico and other microcontroller hardware. As you can see, it's available for Windows, Mac and Linux, so it doesn't matter what you're running, they've got you covered. Now we have all of our basic building blocks, we can start to put all of this together. Before the Pico can really do anything useful, you need to install some firmware onto it. Now you can get firmware to do all kinds of things on the Pico, but what we're going to install is Micropython. This is a very lightweight Python runtime environment and is specifically designed for microcontrollers. You can pick it up from this website here, and I'll put a link to it along with everything else you see here in the description below. If you scroll down just a little way on the page, there are a couple of download links. Just follow the one for the Raspberry Pi Pico W. This will download a firmware file that has a .uf2 extension. We can then go about copying this onto our Pi Pico. In order to copy Micropython onto the Pico, you need to connect the power to the Pico while you're holding the button that's just located on the top of it, just as you can see me doing here now. Once you've done this, you'll then be able to mount the Raspberry Pi Pico as a new file system on your computer. Once you've got the file system mounted in exactly the same way as if you'd attached a USB thumb drive or an SD card, you'll see the file system appear. After this, you can just go to your downloads directory, select the Micropython firmware file and copy it, and then paste that onto the Raspberry Pi Pico. Once the copying is complete, the Pico will unmount itself and restart. Now, if you start up Thonny, you'll see a display like what you see here. If you don't see that triple chevron prompt, then just check in the bottom right hand corner that it's reporting that it is connected. If it's not, just click the button in the bottom corner and you'll get all of the different connectivity options. Just select the one for the Micropython Raspberry Pi Pico. That should then connect just fine. Now we've got this, we can actually run some fairly simple Python commands just to prove that we can actually execute Python on the Pico. This code is actually executing on the Pico itself. It's not running on the local computer. Now there are a whole lot of libraries that are already built for MicroPython that you can install. All you have to do is go to the Tools menu and then click on Manage Packages. In here you can just search for packages that you want. Right now I'm just going to look for one called MicroPython-machine. And now it's found it, I'm just going to install that. Now that's installed on the Pico, and I can see that if I go into this lib directory, you can see it's imported machine and a whole load of other stuff as well. And now I can write some very, very simple code to turn on the LED on the Pi Pico. And here you can see that the LED has come on. And indeed, I can call LED to off to switch it off again. Now, before we can get the Pico talking to our BME280, certainly for the Adafruit version anyway, there's one little annoying compatibility issue that we need to fix. If you double click on lib and then into machine, there's a file in here called __init__.py. If you open that up, then we need to comment out lines 2 and 3. So just put a hash or a pound character in at the start of those lines, and then click the icon to save that. Now the next step is to get the Pico talking to the BME280. If you get the Pimaroni version of the BME280, and maybe others as well, this becomes really easy. You can just go back to the Manage Packages window, and then search for MicroPython-BME280. And you can see there's a library available for it. Now, unfortunately, the Adafruit version of the BME280 doesn't work with this library. It's a whole lot more complicated to set it up. But if you don't have the Adafruit version, just go with this library to start with and just see if it works. As I have the Adafruit version, there's a whole lot of extra software that I have to install and set up first. You can get all of that from this site here. Again, I'll put a link in the description below. If you scroll down, there are a couple of links to software here. The latest Blinker library from Adafruit and the latest Platform Detect library. Both of these link through to GitHub repositories, and in both cases you want to download the source code tar.gz file. A little further down, there's then a link through to the CircuitPython library bundle. Now if you select this, and then scroll down, there are a number of download links available. The one that you want is the one called Python Source Bundle. Just click on the provided link and download that zip file. Now I've provided a load of scripts and software myself to get all of this working. All you have to do is either clone this repository or you can use the download zip option. And once you have it, you just want to open a terminal and go into the Pico directory. So I have all of this cloned in this directory here. Now I'm going to make a directory in here called Prepare Adafruit Libs. And I'm going to move into that. I'm now going to copy over all of those libraries that I downloaded from Adafruit. And you can see I have those in there now. I'm now going to copy in a setup script that I've got in my GitHub. And I need to make that executable. Now if I run this, this will extract all of the relevant libraries that MicroPython needs to be able to talk from the Pico to the Adafruit version of the BME280. Now that's done, it cleans up after itself, so I'm just left with the libraries themselves. And if I go back to Thonny, now I can copy all of these libraries onto the Pico. All I have to do is double click on the lib option and then go to Prepare Adafruit Libs, select everything I need except for the setup script itself, right click and then select Upload to /lib. This will then go ahead and upload all of these libraries onto the Pico. Now we've got all of that set up, we can go ahead and get the Pico actually talking to the BME280. Now the first thing to do here is in the lower window, just click Raspberry Pi Pico. In the upper window, click on Pico, and then open up BME280 reader.py. Now if you've got the non-Adafruit version of BME280, you could just try running this. It's a class I've written just to wrap up the functionality of the BME280. Now you can create an instance of the class just by providing the numbers of the pins that the BME280 is connected to. Just try running this. Now in my case, this doesn't work because I've got the Adafruit version, but on your BME280 it may well work just fine. If it does, brilliant. If it doesn't and you've got the Adafruit version, then use this version of the class instead, BME280 reader_adafruit.py. This is a specialized version of the same class that is designed to work with the Adafruit version. If I run this, then this should work just fine for my case. And yes, and there you can see that the temperature, humidity and pressure data is coming through just fine. So now let's go and take a look at some of the other Python code that I've had to write for this. The next class I want to talk about is the Wi-Fi class. Now, as I mentioned earlier, the Pico doesn't really have an operating system as such, and so you don't configure Wi-Fi in the same way as you would on a Pi Zero or any other Raspberry Pi model. Instead, you've kind of got to code it. In order to do this, I've prepared this class here, and it goes through everything that the Pico needs to do in order to connect to your Wi-Fi network. Now, I've made a couple of modifications here just for the purpose of the video, so it doesn't display what my Wi-Fi's SSID or password are for obvious reasons. You configure these in this file wifi_creds.json. Now this can take an array of network connections if you happen to have more than one Wi-Fi network available. If you don't, just reduce this down to one set, and then against SSID you just put in the name of your network, and in password you put in the password that you use to connect to your network. When you've got that configured, just copy it onto your Pico by right-clicking on the file and saying upload to /. In my case, I've got a prepared version that I've got under this directory here, and I'm just going to upload that. Now that's in place, I should just be able to run this Wi-Fi class, and it will then try to connect to my wireless network. And there you can see it's been able to connect successfully. The next class I want to talk about is ntpclient.py. Now the Pi Pico does have a real-time clock chip installed on it. However, it doesn't have any battery. So when the Pico gets reset, it's got no way of knowing what the time was. So it just sets back to 1970. So now we've got a way to set up a Wi-Fi connection. I can use the protocol NTP to call out to an NTP host server and then retrieve what the current time is. Once that's been retrieved, I can then call into the real-time clock to set what our current date is. And I've got some code here that will just test that out. It makes use of the Wi-Fi module we were just talking about, and then it calls out to pool.ntp.org to get what the local time is. It then calls this method to set that time. Now before we can use this, we need to copy our Wi-Fi module onto our Raspberry Pi Pico. And so I can just do that by right-clicking on wifi.py and saying upload to /. And there you can see it appears. Now I should be able to run this test code for NTP client with no problem. And here you can see that it's now been able to retrieve and set the time successfully. The only downside was it took a little while before it could connect to the Wi-Fi in the first place, but once it did, it was fine. Now we've successfully tested the time module, I'm going to copy that onto the Pico as well, just by right-clicking and saying upload to /. And there you can see it's uploaded onto the Raspberry Pi Pico. The next class is colorcalc.py. Now anyone who saw my last video will know what this is all about. This is just to provide a colourful background for the temperature sensor so that for any given temperature, the background will change. Now just to give you an idea about what this looks like, this is some test code that I ran against it. So depending on what the temperature is that is measured, I can pass it into this library and it will give me a colour value back based upon that temperature. So you can see it starts out in deep blue and then moves through the blues into the greens as the temperature rises, then off into the yellows, oranges, and ultimately the reds. Since in the UK we tend not to have an awful lot of temperatures that are below -10 or above 30, I've limited it to that range. After those points, the colours will stay just dark blue or red respectively. And now if we go back to our code, I can copy that onto our PI Pico. The next thing that we need to copy onto the Pico, of course, is the actual BME280 reader library. So I'm going to pick my Adafruit version and then copy that over to the Pico. Now all of our basic building blocks have been copied over, and we can actually look at the main code. That's in WeatherStation.py. Now this is quite a complex class, and it actually brings everything together. So it sets up the Wi-Fi connection, reads in the time and sets the clock. It configures our BME280 reader and sets up the color calc class so that we can display things properly. If we look at the main section of the class, that's this serve method here. Now here what we actually do is we set up our own little mini web server. Following on from setting up the Wi-Fi connection, I then set up a socket to listen on our IP address on port 80, the HTTP port. It then just waits for connections to come in from browsers, and for those browsers then to send in requests for pages. I chop up that request so that I can get hold of the actual path that was specified in the request. So just as examples here, if /data is provided, then this is kind of equivalent to in the last video where on the Pi Zero I was using Flask and a route called /data in order to get my application to go off and retrieve the data from the BME280. I do the same thing here, and if I get a request coming in for /data, I then just make it call the getData method, which constructs this JSON data containing all of the weather information, and send that back to the client. There are then some specific files that I parse for as well. If the user requests the default page for a website, I then retrieve my index.html page. I've also got handlers for the jQuery text fill library, WeatherStation CSS file for all the formatting, and my WeatherStation.js file, which is the JavaScript. For all of those, they end up calling this method here, sendFile. This is passed the name of the file that we need to render, what the MIME type of the return is, and the client that requested the data. The first thing I do is I go off and find out how big the file is that I need to return. I then open that file up and I read the contents in. I then construct this HTTP response string. You can see I've got to specify all of the headers myself here, including what the MIME type is and the size of the data. And I then send that back to the client. Now all of the files themselves I've hidden into this web page directory. So in order for these to be served out by my software, I need to upload this onto the Pico. I can do that just by right clicking on web page and saying upload to /. Now my little mini web server here just runs round in a loop, just waiting over and over again for requests to come in from various browsers. So I'm going to reset my Pico here and then we can try running this. So firstly, it's connecting to Wi-Fi. Then once it's got its Wi-Fi connection, it will go off and set the time. And then it will start waiting for browser web requests. And here you can see some are coming in already, and let's go and take a look at the browser to see what it's doing. And here you can see that the browser window is updating nicely. Now we have all of this running. That's really great. But the problem is, we don't want to have the Pico always connected to our Thonny IDE in order for it to be able to work. Instead, we want it to be able to start up automatically. And it turns out that that's really easy to do. So let's go and take a look at that. Now, just before we move any further, I've just reset the Pico again, just by disconnecting the USB cable and plugging it back in again. And I've also hit the stop button on Thonny. Now, firstly, let's just go ahead and upload the WeatherStation Python file onto the Pico. Now, when the Pico starts up, by default, it's going to look for a file called main.py in the root of the file system. I've prepared one here. And you can see all it really does is it starts up one of these weather server objects. And then in an infinite loop, it just calls the serve method. So it's just constantly waiting for the connections coming in from the browsers and then serving out the responses. In order to make the Pico auto run, all I need to do is upload this onto the Pico and then reset its power again. So let's do that right now. Upload to slash, and then main.py is there and available. Now what I'm going to do is I'm going to completely shut down Thonny, and I'll pull our little view of our BME280 into the middle of the screen. Now the USB connector that you can see there is connected into my PC. What I'm going to do is I'm going to replace that with a direct power connector, so there's absolutely no connection to the PC whatsoever. Now when I connect this, there's obviously no logging or anything like that we can see on a status display. So to help us out, I put some code into the Wi-Fi module so that when the Wi-Fi is connected, the LED on the Pico will light up. So now I'll just go ahead and swap over these cables. There, now we can see the light has illuminated on the Pico. And that means it's running and it's connected to our Wi-Fi. It should now be serving up the web page. So if I switch over to the browser, you can see that indeed it is now getting data. And what's really great about this is it means that I could put this Pico and its BME280 literally anywhere so long as I could get a power supply to it. And that includes outside. I could take a weatherproof project box, mount the Pico inside it, and then I could use that to measure the temperature outside. Or I could put them all over the house and then extend the browser display so that it showed me the temperature everywhere. And each one of these little units can cost as little as about £20 when you consider the cost of the Pico and the BME280 itself. Now, of course, there are other ways that you could get devices to show you temperature and pressure and humidity that would have their own little displays. But the problem is you can't see all of those at the same time. They're not web enabled. So to me, the extra cost is worthwhile, since you have absolute control of what you want the end product to look like. Plus, you get the satisfaction that you put it all together. And so now we've been able to put together a rudimentary WeatherStation, both using a Raspberry Pi Zero and a Pi Pico. In my next video, I'll be taking this a stage further by adding a device called an anemometer or wind speed sensor to the WeatherStation. I'll be doing this against the Pico version, but you can do this with the Zero in exactly the same way. So stay tuned for that. Once again, if you like what you've seen here, please click that thumbs up button. Subscribe if you want to see more, and hit that notification bell to be notified when I put out another video. And let me know in the comments what you thought about this project. And again, if you've got any ideas for projects that you'd like to see me do in the future, let me know there as well. Thanks so much for watching till the end. And until next time, bye for now.